Hello, this is a demonstration of Copernicus 2. This is the first system that performs actually trustworthy collection of system BIOS information, including the configuration to determine whether or not the BIOS is vulnerable to attacks, and the raw contents of the BIOS itself to determine whether it's been infected. So with Copernicus 2, it comes with a README file, which you should of course read. It's built on top of Flickr, which is an open source project for using Intel TXT trusted execution technology. So it's necessary to have a system that supports both Intel TXT as well as the trusted platform module, because TXT depends on the presence of a TPM. So we believe that it'll work with anything that Flickr supports, but we've only actually tested it with a system that we have that's on this compatibility list. So your results may vary. After you follow the installation instructions, which includes configuring the TPM and turning on TXT and installing a few pieces of software, then running Copernicus 2 is very simple. You basically just take the files which you've copied to c:"cop2/bin and hit run. So now we'll go ahead and run Copernicus, simple batch script. And what it's going to do is it's going to do a number of actions all in sequence. But the important part is that it collects the information, and after it's collected the information, it gives you some evidence about whether or not you can trust the information. So at the very end, what you'll see is three outputs, three PCRs, platform configuration registers from the BIOS, or from the TPM rather. And the information that we measured in our trustworthy TXT land is stored into these platform configuration registers. So what we want to be able to do is see that these values here in PCR 17 and 18 match the values that we reconstruct with the data that was collected from the kernel. So PCR 17, we see that it is the same 3E, etc. SHA-1 hash, and PCR 18 is the same 706, etc. hash as well. So what this means is basically the trustworthy collection and the untrustworthy collection in the kernel were able to see the same information, and therefore there's no attacker who is currently subverting the view of the kernel-based collection. So going into a little more detail about what's occurring, when the batch script starts running, the first thing it does is it installs Corey Kallenberg's OpenTPM kernel driver. That allows user space programs to send messages to the kernel to talk to the TPM. Then we run some user space programs that take ownership of the TPM and provide a little temporary password. And this can error out if you've already done this before on the system. It calls identity.exe, which creates a TPM identity key, which we'll be using later for assigning the results which are coming back from the TPM. It then loads that key up into the TPM using load key. And then that's stored within the TPM, and we can use that to ask the TPM to perform signatures for us later. After that, we start Flickr, the open source TXT system. And after Flickr is started, we provide the host name so that we can put some extra information into the output so that the output's more human readable. And then what we do is we call the Flickr driver control, which is user space application that provides information to the kernel side before starting TXT. So you'll need to figure out the correct SINIT module for your system in order to run this. There's different SINIT modules for different pieces of Intel hardware. And then the COP2 PAL, or piece of application logic in Flickr parlance, is the actual executable code that's run in the trusted domain, and that does the same sort of collection of the BIOS information and configuration information as the kernel side. And so then once we say go, Flickr goes out, runs our code, and it puts the data into those TPM PCRs. After the trustworthy code is run within Flickr, then we call our normal Copernicus code that runs within the Windows kernel. We start up our driver, it collects the data in a less trustworthy way, and it just stores that data off to disk. And so once that's done, we have all the data we need. We have the trustworthy data stored into the TPM PCRs, and we have the untrustworthy data stored to file so that we can try to reconstruct the values. And so if these values in 17 and 18 match the values printed out below by the Python scripts, then that's good. And you also want to make sure that it says successfully verified the signature on the TPM quote. This is using the key that we provided before to indicate that the data coming back to us was signed with that key. Now in practice, you would want to generate keys at an earlier time and install them into the TPM earlier. We're just doing it on the fly in order to show the entire life cycle. So that's the basic run of Copernicus 2. As you can see, we've put a script around it so that pretty much all you have to do is run it and then confirm through looking at the output that you see the same data returned by the TPM as we reconstruct independently. For people interested in seeing a little bit more behind the scenes what's happening with Copernicus 2, or who may be experiencing an error and want to find an error message to send us so we can help debug it, here's a little bit more about what's going on behind the scenes. So first of all, the easiest way for people to collect information output by Flickr is by using the sysinternals tool debug view. So you're going to want to go download debug view and run that as administrator. And then you're going to want to select capture kernel and enable verbose kernel output, and then turn off the Win32 output. So this is a simple standalone way to collect this information, but I'll also show collecting it through WinDebug. Over on a second system that we have right here, we have WinDebug set up as a kernel debugger using Firmware debugging. So we can break into the system and we can see whatever output's happening. We can inspect arguments and so forth. So this will collect the same information as debug view does on the system proper. But also if you have a second system, you can use serial over LAN. So by default, Flickr and the Copernicus 2 PAL that's run in Flickr provide output via serial over LAN, which can be captured by special Intel tools. So this is the Intel redirection tool, Intel redirection SDK sample. So this is example code from Intel. And so we connect to our system and we select start SOL, serial over LAN. And then it'll start PuTTY and it'll basically be collecting information. Now right now there seems to be an error with Flickr, so on the host side you have to connect with PuTTY as well. So you're going to want to select serial port, you're going to want to change it to COM3, and you're going to want to set the speed to 115/200. And then go ahead and note OK. And now things that you send on one side will show up on the other side. So it didn't echo out over on this side, but it did show up over here. And I can send a message back. And it echoes on this side, but not on this side. But the message was sent over. So now, over here on the remote side, this is where the Copernicus 2 PAL output is going to be seen. So you'll be able to see it doing its work a little bit more. So now let's just go ahead and start it again. And when we hit run, if we go over to debug view, for instance, well, the system is, while Flickr is actually running, the system is exclusively doing that output. But this is some example of the Flickr output, just showing the type of memory management that it's doing and so forth. But if you look at this output and you see something like it says, unable to start or unable to S-enter and so forth, then you'll know that the issue is with Flickr. But if you see TXT launch environment resumed, that means we got into Flickr and we were able to get out of Flickr, and everything worked out well. So over on the other side, we see output from the same sort of output from WinDebug, and again, here's some just memory management type information for those who are interested. But the more interesting thing is really the serial over LAN output. This is pretty much the only good way to see what's going on in TXT LAN. So this is the type of information, such as the untrustworthy version of Copernicus will collect this same information right here, the CSV information that indicates whether or not the machine is locked or open for writing. The same information is collected by the kernel side, and that's how we're able to reconstruct the actions that were happening within Flickr. And so speaking of that data, the actual raw data is stored one directory up. And so you have the raw Copernicus BIOS, that's the contents of the BIOS. You have the CSV output, that's the information about whether or not, that's the information that the normal Copernicus protections.py will be able to use to determine whether or not a system is vulnerable to writing. You have the log, which just tells you if there was any Copernicus specific errors. Then we have TPM quote, which is written out by this last tool here. Eventually we'll make it so that it's basically seamless, that quote will be consumed and we'll reconstruct the values, and it'll just say, pass or fail if the signature verified and so forth. And then we have the TXT heap, and this is information that's needed to reconstruct the PCR values as well by these scripts. So that's pretty much it for Copernicus. This shows you some ways that you can see the raw information that's happening behind the scenes. And similarly, ways that you can detect whether or not where any errors may be occurring. But if you have a problem and you'd like us to try to work through it, then this is the kind of information we're going to need. Alright, thanks for checking it out.